So our quick look at the calendar tells us that we are on our third day of systems of equations. This class and then our next class, Friday, are all about applications. Said another way, word problems that all involve systems of equations. We have 2 days on these word problems. The word problems today are generally speaking easier than the ones that we're going to see on Friday. So let's jump in with the more straightforward ones today. Again, on page 65 in the packet. And we'll start with the daily summary. Virginia, could you read that for us? Thank you. Sam, number 1. Okay, so we're going to go through these kind of quickly. I want to make sure you have a lot of time for the activity to really struggle through these word problems today. I said the ones today are more straightforward than the ones from Friday coming up, but I'm not saying they're easy. They're not easy. Okay, so the first step is to define our variables. We got a lot of stuff happening in this problem, but to define your variables, you just go to that very last part. The question itself is my way of telling you what the variables should be. How much of each type of candy should be included in the mixture? Those are our 2 variables. So we've got 2 kinds of candy here, some stuff that's $2.50 a pound and some other stuff that's $4 a pound. So how about we let C equal the weight of the cheap candy. In pounds. We're trying to find out how much of each kind of candy. There's some cheaper stuff and then some more expensive stuff. Can you put that away, please? And then we'll go ahead and let E equal the same thing, but the more expensive. So again, to figure out what your variables should be, go to the very end of the problem. There's a very explicit question there. That's what your variables should be. Now we're going to fill in some stuff in the table. So first, we're going to fill in the cost per item. I'm arbitrarily going to put the cheap stuff on the top row and the more expensive stuff down below. So let's start filling in. Cost per item. What's the cost per pound for the cheaper stuff? It's $2.50, so I'll put $2.50 there. And then the more expensive stuff is 4 even. And then total doesn't really have any meaning. I mean, I guess you could add them, but it doesn't contribute anything to the problem. Okay, first column now. It says number of items. Okay, number isn't really the right word, but this is kind of a generic table. The number is really the weight, like how much of the cheap candy are we buying and how much of the expensive candy are we buying. And those are the variables we introduced. So what letter goes in this first box? C is our definition for how much of the cheaper candy we're buying. And then E is our definition for the amount of expensive stuff. Now the total should be a number that's in the problem. The total weight of the stuff is 5 pounds. That total is a number that's in the problem. 5 pounds of candy altogether. Well, it depends on how many people we're going to feed. We've got Halloween coming up, so maybe we're preparing. Total value. Let's go over to this last column. Here's the idea. If we set these tables up in a consistent way, then we're going to have multiplication equaling the final column. Let's make sure we believe that. Let's look at this row right here. How much does each pound of expensive candy cost? $4, and we are buying E pounds of it. So like if you buy 3 pounds of it, then how much does that cost you? It's 12, right? It's 4 times 3 or 4 times E. So 4 times E is what goes over here. The total value, the worth of that expensive candy is 4 times E. And in the top row, 250 times C. And again, you could write 2.5, yeah. Yeah, I'm going to keep the 0 the whole time because it's $1, but you could drop it. Okay, And then this last empty blank, again, every number in this bottom row, every blank in the bottom row should get filled in with a number. So the total value of all the candy is a number, which is 1760. And just grab that from the problem. Okay. All right, so we filled in the table. And now we're going to write a system of equations. One equation is going to describe the number of items, a little typo there, number of items. And the other equation will describe the total value. So let's see if we can grab these equations. So looking at the first column, the number of items, you bought C pounds of the cheap candy, E pounds of the expensive candy, but altogether it's 5 pounds you want. So do you see the equation that comes from that column? 5 equals C plus E. That's it. And then the other equation comes from the last column. You've got the value of the cheap candy is 250C. The value of the expensive candy is 4C, but the total value of all that candy is supposed to be 1760. So it's the same format for the equation. 250C plus 4E equals 17.60. Sam?
I just found the numbers into the numbers you gave us into the second equation. If you could apply it on there.
Numbers I gave from the second. I'll check it in a little bit. Okay. All right, so we've got our two equations, and then you would solve your system of equations, but I'm going to ask you to do it later. Now, Sam has already jumped ahead, and there might be a mistake in here. I think the answers are 1.4 for the cheap stuff and 3.6 for the expensive stuff, but I don't want to spend our time solving the system. I just want us to make sure we can set up the system. That's the new part for today. You had plenty of practice solving when you did your homework for today. Okay, any questions on this example? All right, so let's look at one more example, and it has to do with money. Let's go to Fiona for number 2. The amount, the. Go ahead. Okay, so here's a formula that you might have seen before. It's certainly one that you probably will believe even if you don't know the particular letters. But if you take the amount that you invest and multiply by the rate, that gives you the amount of interest that you get at the end of 1 year. So let's go to 3. Casey?
Gary invested a total of $1,000.
Okay, so there's a lot going on in the problem, but let's break it down into its pieces. First step again is to define the variables. Where should we go to figure out what the variables should be? Is the question itself. How much did he invest at each rate? That's what our variables should represent. So we've got a low rate and a high rate, 4% and 9%. So how about we let L equal amount invested at the low rate in dollars. Make sure you put units in every one of your definitions. And then H can equal the same thing, but at the higher rate. There are a lot of steps to these word problems, but this is supposed to be an easy one if you know where to look. Just go to the very end, look at the question itself. That's what your variables should be. Okay, so now we're going to fill in some stuff at the table. This middle column is typically the easiest one. I'm going to go ahead and, again, arbitrarily put the low in the middle and the high. The low is the top row for me, and then the high. So what's the interest rate for the low? It's 4%. Okay, you could put 4 here, and you're going to get in trouble if you do that. What should I put there? We should put 0.04, because we're going to be writing down equations in a second. And if you have percentages inside of equations, you got to make sure those percentages are converted to decimals. So any interest rate has to get converted to a decimal. What's the high rate as a decimal? 0.09. 9% becomes 0.09. And again, the total interest rate doesn't really have any meaning. I'll put a line through it. Okay, first column. The amount of money invested at the low rate. It's one of our variables. What is it? L. And the amount of money invested at the high rate, H. A total is a number that's in the problem. 2,000. We invested a total of $2,000. Okay, let's come over here to this last column. I'm going to highlight this equation at the top first. This I equals P times R. The amount of interest you get is your principal times your rate. Okay, let's take a look. What businessy word describes the amount of money you invest in something? It's principal. This interest rate is symbolized with what letter up there? And it's tricky because there's an I, but it's really the R is the interest rate. This right here is the R. And then the amount of interest income is what letter? That's our I. And we know, based on that equation, that if you multiply the P times the R, you get the I. So I'm going to say this first column times the second column equals the third column, which is exactly the same pattern that we had in the previous table. So even though the candy really has nothing to do with this investment problem, they can be set up and solved in exactly the same way. First column times second column equals last column. Okay, so now that we've got that, we can just multiply these things and put it in the last column. So 0.04 times L. That's what we'll put over here. And the next one, 0.09H. Okay, and the last blank is often a problem, a number that's just given in the problem. Are we told the total amount of interest that we get? We aren't, so we can't fill that thing in. But there is another piece of info that we haven't used. What number haven't we used yet? This is a 37. Okay, so I'm just going to circle it. Let's see, it says the income from the 9% is 37 more than the income from the 4%. I don't quite know how to translate that yet, but definitely I have to use that fact. Let's come down here and start writing our equations. First equation comes from this first column. L plus H equals 2,000. It's the same pattern as our candy problem. L plus H equals 2,000. Okay, now the other equation. In the candy one, we got to just say this guy plus this guy equals $17.60. We're not so lucky in this problem. We have to translate that circled phrase up there into symbols. The income from the 9% investment. Income from the 9% investment. Does anybody see that expression in this table? What's that exactly? That is the income from the 9% investment. Yeah, it's something like that. It's either that or the 37 on the other side, but that's exactly what we're after. Is that this blue thing is the income from the 9%. I'll highlight in green. The income from the 4% is this guy, and we just have to somehow get an equation with that 37 in it and these two highlighted things. So let's translate very carefully. The income from the 9%, that's 0.09H, is equals 37 more than. I haven't read that part of the sentence yet. But 37 more than, I know, means 37 plus. And then the 4% income was 0.04L. A lot of ways to get that equation wrong, but if you just read it piece by piece and translate each piece into symbols, I think you'll get it right. And again, I'm not going to spend our time right now solving. We'll have plenty of time to solve during the activities. But if you solve later on, if I did this right, should get 1,100 at the 4% rate and 900 at the 9% rate. Okay, so let's just, before we go to the group activity on the next page, well, actually on the next page is a step-by-step process, which you can read through later on or have it with you as you're working through the activity. And then go to the page after that, which has activities at the top. So we're doing things just a little bit differently today. There are 5 problems in this activity, and I'm hopeful that the groups can get through all 5 of them. But what I'd really love to see is each problem written out up on the board so that people that don't get to all 5 can at least reference these things, maybe take a photograph or copy in your notes or something. So what you guys are going to do is you're not all going to start with number 1. You're going to start with different problems, right? But whatever problem you start with, that's the one that you have to put on the board once you're finished with it, okay? So the goal is to do every problem, but you're starting with different ones. Okay. Yeah, as soon as you finish your problem, you move on, but it's your responsibility to get that problem as a table up on the board, okay? Okay, so this is table 1. You guys are starting with number 1. Back there, you're starting with number 2. Number 3 back here. You guys are 4. And then these 2 tables in the front, you're both starting with 5.